Alright, so here I have another example of two binomials. Rad5 plus 4 times rad3 plus rad5. So notice that, okay, this is similar to the last one, but notice that I have two terms for each piece. So I'm going to have to use FOIL method or distribution. So let's FOIL this out. So the first one, rad5 times this and times that one, and then 4 times this and times that one. So rad5 times rad3 gives me rad15. And then rad5 times rad5 gives me rad25. 4 times rad3 gives me 4 rad3. And then 4 times rad5 gives me 4 rad5. And then what I can simplify is this 25, rad25. 25 is a perfect square, so it gives me rad15 plus 5 plus 4 rad3 plus 4 rad5. So after we multiply, we have to look for like terms to add or subtract or combine them in general. But in this case, we can't combine anything, so that's it for this. This is the answer. Alright, so this one is similar to the last one for you guys to try, so go ahead and pause the video, we'll go over it together. Alright, I have 3 rad3 minus rad7 times 2 rad3 plus 5 rad7. So let's FOIL this out. 3 rad3 times the first term and then times the second term. 7 rad7, same thing for rad7. So 3 times 2 gives me 6. So I have 6. Rad3 times rad3, rad9. 3 times 5 gives me 15. And 3 times 7 gives me 21. 15 rad21. And then for rad7, negative 1 times 2 gives me negative 2. And 7 times 3 gives me rad21. Negative 1 times 5 gives me negative 5. And times rad7 times rad7, rad49. And we can simplify this one. Rad6 is, rad9 is a perfect square, and it's 3, and 3 leaves the radical. 3 times 6 gives me 18, plus 15 rad21 minus 2 rad21. So this is like, these two are the like terms. I have to combine them, this one and this one. So this is like 15 of something minus 2 of something, so that gives me 13 of that something. So I have 13 rad21, and then for here, rad49 is 7, and 7 leaves the radical, gets multiplied by the 5. 5 times 7 is 35, and it's a negative, so negative 35. And here, my like terms are these two right now. 18 minus 35, so I get 13 rad21 and minus 17. So 18 minus 35 gives me negative 17. So 13 rad21 minus 17. Alright, so here we have another example. 1 minus rad8 times 1 plus rad8. So distribute both of them. 1 times 1 is 1. 1 times rad8 is rad8 plus rad8. Negative rad8 times 1 is negative rad8. And negative rad8 times rad8 gives me negative rad64. And the like terms, to combine the like terms, these two cancel each other because it's rad8 minus rad8, did this example and the answer is -7, but notice that this is a conjugate. It's one, a conjugate is something that when you multiply something by the same thing but with opposite signs. So in general, it can be in form of a minus b times a plus b. So notice that these terms are the same, but just the sign is different. And the general formula for this one, like if you distribute this, you're going to get a squared minus b squared. So that's when you multiply them. And for this one, for example, we could also do that. So a squared minus b squared, a is 1 and b is rad 8. And we can write it as 1 squared minus rad 8 squared. The square sign and this second power and the square root would cancel each other, and 1 squared is just 1. So that gives me 1 minus 8, which is -7, which is the same answer. So if you distribute that, yes, you're going to get the same thing, and that's it. Okay, so here I have another example similar to the last ones that I did for you guys to try. Go ahead and pause the video. We'll go over it together. Okay, I have 3 minus 5 rad 5 times rad 15 plus 3 rad 3. So let's FOIL this out. Okay, 3 times rad 15 gives me 3 rad 15. 3 times 3 rad 3 gives me 9 rad 3. And -5 times 1, the coefficient of this one is 1, so it gives me -5 times 5 times 15 gives me 75. -5 times 3 gives me -15. 5 times 3 gives me 15. So 15 rad 15. The like terms here are this one and this one, -15 rad 15 and 3 rad 15. So this is like 3 of something minus 15 of something. So that gives me -12 of that something. So I keep the -12. I write the -12 rad 15. And then this one, I just write it like this, 9 rad 3. And then for this one, 75. Okay, this is a square, so I'm going to find the perfect square in 75, which is 25. So I can rewrite 75 as 25 times 3. And then I can break out that one to rad 25 times rad 3. So maybe I should write that here. So 5 rad 75 is 5 times rad 25 times 3, and that's like 5 times rad 25 times rad 3, and then this one gives me 5 times 5 rad 3, so this is 25 rad 3. So yeah, instead of 5 rad 75, I can write 25 rad 3. So here we have 2 more like terms, 9 rad 3 and 25 rad 3. So this is like 9 of something minus 25 of something, and that gives me 9 minus 25 gives me -16. So here my final answer is -12 rad 15 minus 16 rad 3. So that's the answer. Alright, here I have an example of 2 binomials that have variables in them. So this is 7a minus 10 rad ab times rad 3b plus 2b. So let's FOIL this out first. 7a times both of them, and same thing for the second term. So 7a times that gives me 7a times rad 3b, and 7a times 2b gives me 7 times 2 is 14, so I have 14a times b. And moving on to here, -10 times 1 gives me -10, and then under the radical get b squared, and I have a 3. So this is 3ab squared. And then negative 10 times 2 gives me negative 20. Negative 20b times rad AB. Okay, so we don't have any like terms. The only thing that we need to change is this one. We can simplify that. We can write that one as, let me write it here. So I have 10 rad 3ab squared. I can rewrite this as 10 rad 3a times rad b squared. And in rad b squared, the index and the exponent cancel each other. Or you can think of it as for every 2 b's, 1 pops out of the radical. So I get 10b times 3a. So that was for this part. So my answer would be 7a times rad 3b plus 14ab minus 10b rad 3a minus 20b rad AB. So that's it for this question. Alright, so that's it for multiplying radicals. Thank you for watching this video.